Hi everyone, in this tutorial I will teach how to use CTNG Analyst for simulating a small urban area. So firstly you need to install the CTNG Analyst, but I will not go in detail on that. You can download the CTNG Analyst file in their website. And then we have a lot of tutorials and information about the software on their web page. But let's start. So when you install CTNG Analyst, you have three objects related with the software. The first one is the console. If you open, you can see that you have an interface that works with that may run the simulation using different codes. So if you type CEA, the different options for the simulation are given, and those are the options that appear on the CTNG Analyst dashboard. So it's just a question of using the console. It's just a question of being a more robust solution. So if you find problems running the simulation in the dashboard, you can run it here in the console. The CTNG Analyst config file has the default values for different inputs and outputs and processing. So at this stage it's not very important, but you can change here the default values of the software. Finally, the CTNG Analyst dashboard is the tool that we will use, or the main use. So let's start. So first of all, we will start with a new project. In this case we will call it small area, and we will save it in a desktop in the CTNG Analyst lecture. Okay. And then we can create inside our project different scenarios. This allows to compare between scenarios. So for instance, if you are evaluating one retrofit scenario, you should have one scenario named baseline, or as it is, or the name that you wish, and on the other scenario you can change the measures that you would like regarding construction systems and so on, and you have another scenario that allows the comparison. So let's start with a new scenario. Let's call baseline, and here you can see that CTNG Analyst asks for the database paths. These database are the information regarding constructions, systems, technology. All the description and detailed characterization of that database is used to extrapolate the inputs of the simulation. So in this case, as the software was developed in the Switzerland and in Singapore also, they have the two databases, one from Switzerland and the other from Singapore. Of course, you should adapt the database according to your area, because constructions and systems may vary from those default database. So in the input data, we can start by generating new input files using tools, or we may import input files if we have the files structured in the way that are possible to use with CTNG Analyst. But let's start with the basics. So let's generate new input files using tools. We would like to have, this is mandatory, is the zone. So here we have the building polygons. Notice that is taken from OpenStreetMaps. We need also the surroundings. The surroundings are the buildings that will shade our buildings, so it's very important for solar radiation estimation, for instance. And we may select all, streets, terrain, and weather. Although weather, it should return some error, so let's not pick weather, and after this first step we may choose our weather file. Here we can go directly typing the city that we like, or just scrolling the map to the city we would like to analyze, or the area that we like to analyze. So let's go here, downtown Lisbon, and try to draw our area. So you click and draw, and you define your site. Okay, you can do something like this. The more the larger the area, more time it will be to define the zone and to create the zone. So let's see what we'll get. So after a while we get this urban area, where in dark gray we have our zone buildings, and on light gray we have the surroundings. So in the in-city energy analyst interface we can see the name of the buildings, number of floors, above ground, below ground. So if you go over with the pointer, with the mouse, you will have the description of the field. And remember, these fields come from OpenStreetMaps. Okay, so if you have your own files, your own shape files, you can use it as long as they have this structure. Okay, so also when you create a zone using this first step, you'll get the typology database, where you have also the building name, but in this case with more information regarding the year of construction, the standard, very important, the first use also very important, and then other uses if that's the case. For instance, if you have one building, you may select here, okay, and change the building type according to your building database. But if you select here, you can see which building you selected in the map. If you go over, you can see all the characteristics of the building. Imagine that this building has one shop in the first floor. You can say that you can change the fraction of use, so it's not only multi-residential, but you can change here 0.9, I don't know, or 0.8, it depends. And then in the second use we can say that is I don't know, an office. Okay, so and with this when you generate the other input files for the simulation, it will consider the different standards. Okay, so both the office, the different uses, so both multi-residential and office with different weights. Okay, so at this stage we don't have any of these inputs, and we have the surroundings. Okay, so these are the gray areas, only for representing the shading. So we have the number of floors and the height, and all the other inputs are missing. Okay, so we have to generate those files. Just to say that when you create your zone, you will have created also a folder with the following information: baseline, remember this is the name of scenario, and you create a folder named inputs, where you have the building geometry, so all the information regarding the zone, the site is the polygon that we defined earlier, and the surroundings. Okay, so you can open these on a GIS software and edit these files. Okay, Also, we have CTNG Analyst creates the building property folder where you have the typology database, that is this one. Okay, so it's the same. So if you go in the folder, you have the typology and also the schedules that you still didn't create it. So after the creation of the schedules, they will be stored here. Also inputs, you have the networks, the streets. Okay, not so used in a thermal simulation, of course. And then the technology has the technology folder has all the information regarding the constructions, the assemblies of the equipment, the components, conversion, distribution, feedstocks. Okay, all the information from the database is here in different Excel files that will be used to generate all these inputs that are considered in a simulation. So this works like a tree. So if you go here to the envelope Excel file, you can here go to the first sheet and you see that you have here for instance the different constructions, so in a different mass values. Okay, so we have here the code that is used for the different standards. Okay, so here is for instance the construction AS1, and if you go to the folder archetypes, or the archetypes are the standards, you can see that you will have that code on the definition of the envelope. So here you can see the different solutions. Okay, so that we are using. So for tightness, for the area filtration, you have different tightness values. There are then associated with the standard. Okay, so if you go tightness, here they are the different values. So for different building types we have different values. Of course you can change, you can add here, and then when you will upload or refresh the software, you have all the information there. Okay, so it's, if you have something like that, you will have if you update it will appear in your in your dashboard. Okay, but I will not do it, but it's what happens. So is it, so you have more information here about the archetypes. So in the use types, okay, so you have again the use types here, and in the folder you have the different use types, scheduling, and internal gains. So for example multi-residential Excel file, we have the different day types, and for the different day types, of course, the 24 hours of the day, and different values for occupancy, appliances. So these are fraction values, so 100% occupied during night. Okay, and then so on. So 10% of the equipment are used. Lighting, the same. You have also the heating and the cooling set points, so set back and set points, process loads or fractions, servers, and electromobility. Also you have a monthly multiplier that you can of course change according to the months. For instance, go to here we have 12 values, and go to August, and August is this one, and maybe 0.4, I don't know, representing the holidays. Okay, you have also the possibility of editing this database on your dashboard. Okay, so you have here the same information. So we are reading the Excel files that we saw before. So now let's create the input files. So as I was saying before, we can edit the zone and typology in all the files originated and created by the City Energy Analyst on, for instance, the QGIS. So we may add the vector, so the zone file that was in the folder of the input building geometry. Okay, so we can add that file and see that all the fields here that are required by the City Energy Analyst to characterize the building zone. So if you have one shapefile, it's a question of adapting and having the same fields, or at least the mandatory fields. So this one, description, category, and reference, are not mandatory, but the other are. And then you can import or use it as your building and zone shapefile. Okay, the same for the topology. Then you must update, of course, the typology, because the typology is always connected with the zone file. So you can see here. Okay, so you must update that typology, or have one typology file also with the same structure. Okay, standard year, first use, and so on. And having this, you can use it and not use information directly from OpenStreetMaps. Okay, so you can use your own information if you have it. So backing up to the GIS, so I will just close this because I believe it's not working if I have this open. So let's return to the City Energy Analyst dashboard, and now it's time to create the other inputs. Okay, as I told you before, there's a relation between the zone and typology and the database, and that relation is here on the standard code and on the first use or the use codes. Okay, so we have there the data about the building schedules, internal gains, internal loads, indoor comfort, set point temperatures, and so on, and the systems. And then what the software does when we do the data management archetype mapper is to assign the building properties and systems from our from the archetypes database. So let's run. Okay, we can run all the input database or database that we wish. Okay, so we can select and unselect, and of course we can select for just one some buildings, or for all the buildings. That it's all what we will do in this case. So let's run the script. When you run the script, one job is created and the simulation is running here. So if you have any errors, you can see them here. Okay, so let's see what happens. So as you can see here, it was a success. So beautiful. We have all the archetypes mapper, all the archetypes and inputs defined. So we may see it, and the execution time was quite low because of course we have a very low or a very small area. So let's return to the input editor and see what happened. So now we should have all the inputs regarding the all inputs that came from the database. Okay, remember that this database is from Switzerland, so some solutions are not right and not suitable for the Portuguese context. So to continue with our simulation process, we should go to the weather helper. So we must define our weather file. We have some defaults weathers, but of course we can look for the file from our city, that in this case I have here. Let me just copy that file, that Lisbon file, to our folder. So you don't need to do this, but it's just a question of organizing the data. So let's use the weather file, the Lisbon weather file. Okay, so now we can run the script, but just to show you what the weather file has. It has 8,760 values of solar radiation, temperature, relative humidity, and so on. So this is the file representative of the last 30 years. But you can get real data, or at least not real, but because this is real, but more updated data, and then change the file, of course, the weather file, and then use it. Okay, so let's run the process and see what we get. So the script is completed. It was even faster than the other one, so it's very easy. So if you have access to the file, it runs without problems. And then let's continue our data management. The surroundings we don't need, because we have already the surroundings, and we have the terrain that we also have. As it says here, this tool results in a terrain file that has a fixed elevation. In this case, I believe it's 0, so it's not real, but we must have a terrain file for doing the simulation. If we go to our folder, we can see that the terrain file should be here in topography. Okay, so here is the file, is a TIF file. Of course, if you have the TIF file of the slopes of your city or your area, and they are relevant, so they are not flat, you should use it instead of this default one. Let's proceed. So in terms of data management, you also have the street helper, although streets are not mandatory for the thermal simulation. So let's go to the demand. Then in the demand forecasting, we must first sequentially run this script. So first the building solar radiation, after the building schedules, and the building energy demand. These are the scripts that take more time to run, especially the building solar radiation. That has said here, it uses the day sim to calculate solar radiation. So it considers all the surfaces of all the buildings, and the solar radiation that it's incident in that surfaces in the hourly basis. So it takes a while to run, but let's run our building solar radiation. So we have all the buildings, some questions about the processors and the multiprocessing options, and then some values about the day sim that you can try to understand if necessary in the CTNG Analyst glossary or documentation. And you have some advanced fields, number of CPUs. This is again to run more fast or less according to your machine, and other values that you can use. For instance, the roof grid, walls grid. So it is the resolution of the calculations for the day sim, and you have maximum and minimum values that you can consider. But let's neglect this at this stage. I have also here some variables that you can change if you like so, but in this case let's neglect all the changings and run as it is. Again, a new job is created, and it takes a while to run. So here we have our radiation script results. So at least the status says success. So let's see. Didn't take as long as I was thinking, but still 300 seconds. So but remember that is a very small area. So let's see where the results are. So if you go to solar, no, it's not this one, but it should be something like that. Okay, let's go topography, and then we are starting now to having outputs. Okay, so the solar radiation is considered an output, so it's the first output that we get. So output data solar radiation, and now we have all the files for all the buildings. Okay, we have the CSV file with the data, and then we have a JSON file also with installation in an hourly basis. We can open this one just to see, take a look. So we have different information regarding the calculation of the solar radiation in the different surfaces. So this is the building one with a different surface and so on. So we have the areas, the walls, roofs, and so on. So let's see what we get in the dashboard. Now it's time to run. We were here, now we go to the next step, the building schedules. So to estimate both the occupancy profile, but not just the occupancy profile, also the building, the equipment and the lighting use in an hourly basis. So let's run these building schedules. We can select the stochastic or the deterministic schedule modeling. In this case, we'll consider the default one, the deterministic, but we can consider stochastic as occupation. Of course, it's not a deterministic subject. So we have more information again about the CPU. So it's a question of defining the CPUs that will run this script. So let's run and see how long it will take. So now this was fast, so only 17 seconds. And then what we have now use types. Yes, so this is one or not. Yes, it's this one. So now we have, okay, the occupancy schedules. Let's see. We open the first one and we will have something like this. Okay, so this is for the building B1000, and we have again all the hours of the year, the different values that came from the database, and we have all the values for our buildings. Okay, for our buildings, so different parameters regarding this is regarding appliances, lighting, I don't know if it's electrical vehicles, but you can see in the glossary. Okay, here it's what waters I know, but some I don't know, but you can see in the glossary what are the different variables. Okay, so the schedules are done, and finally we will run the building energy demand. Again, we can use different, we can ask for different loads outputs, mass flows outputs. So now it begins to be much more complex and much more detailed. So we can ask for different outputs. These outputs are on the software glossary, the software web page. So we can go here, and in the outputs get demand, I believe. Let me see if I can find. We have all the outputs, okay, that we can ask. So call requirement and so on, and a lot of outputs you can see here. But let's return and run as it is, so without changing any of the outputs list. So we had our results from our demand, so the script demand, also very fast again. So let's see what we get. So it's not, I will close this one definitely. So here, if we go to outputs data, we'll have our demand folder. Okay, so there, City Energy Analyst does the demand or does produce the outputs per building and the total, okay, but per building it is something like this, okay, something like this, no, it's like this. We have all the hours in a column, and then we have the values for each hour across the columns for the different variables, okay. So we have a lot of outputs. Of course, some outputs are zero values because they are not related with our case study. So the coal, for example, the coal use or something like that. So this is a very simple simulation that we performed. Now we can create dashboards, but before that let me just simulate the energy potential for photovoltaic panels. Okay, so we have different options for the energy potentials, but we cannot run all, but we can run just one. So we are running this type of panel that again it's in the technologies of the database, and we have here the tilts of the panel, the threshold to consider the simulation. So only above this threshold it will be considered. Of course, you can change and so on, and different parameters to change. But in this case, let's keep the default values, and let's run the script for the PV potential. So the script is completed. So just to show you what type of information we have when we open the more info panel, we have all the description of the simulation, all the running process. Okay, so the information, the calculations for the different surfaces, the potential for solar and PV, and that's it. Okay, and then we have a resume or a brief description of what was done. So again, the outputs are on the output folder. So data, we should have something like solar. Okay, no, not solar potentials, solar, and here they are. Okay, so both sensors in terms of where they are located, I believe, and in the surface, and the PV performance according to the PV technology that is described in the database. So let's return to the dashboard and let's develop a dashboard from nothing. So we can add a plot, and we have different hypotheses. So here in the scenario comparison we don't have anything because we just have one scenario, but as I said before in the beginning of this tutorial, we may have different scenarios and then do comparisons between the scenarios where we can, for instance, compare costs or emissions. Okay, but the energy demand, we can have a comfort chart that is a very beautiful chart. Let's see, one building, the fifth. So we have here the comfort chart. Okay, so where we have the summer comfort zone according to ASHRAE, I believe. So we have a range of temperatures, indoor temperatures, operative temperatures, and we have humidity. So we have a range where people feel comfortable according to this standard in the summer, in the winter period, and you have the number of occupied and unoccupied hours of this building that rely on that area. Okay, so with this we can calculate the number of hours of discomfort of this building. Okay, so if we improve the building envelope, of course the hours should fall more inside our comfort area. Remember that this is the Switzerland case, so we are using the database from Switzerland, so that's why we have such a comfortable pattern, because if it was for Portugal's, the hours should rely on or should fall more in this area because the buildings are much less insulated and much more uncomfortable. So we can add this spot, and then we can, as this is made in Python has this, this possibility of going, of zooming. I don't know how to zoom out now. I don't know, but it's a question of exploring. You can, of course, delete the plot and add other plot. Let's see, solar potential, solar radiation. Let's see what we have here. Technology potentials, the photovoltaic, that it was the last that we run. Let's see what type of graph does the City Energy Analyst produce. So we have a large majority of the energy production is on the roof, and of course in the south facades. So we have here the profile for the different electricity produced by that PV system in that building. Okay, this is not the building, this is all the buildings, but we can do it individually. It's a question of selecting the right plot, and then we can, I believe, to export this image, pen block select, I know we can, so it's a question of exploring these options and try to see how to show plot data files. Okay, let me see what we have here. So it says where the files are in the folders in the path for the folders. Okay, so it's not this. Let me this toggle. This is for the legend, and then change plot. Okay, I know it's possible, but I'm not finding out. It's a question of exploring. Sorry, I know it's possible to export this in this graph. Okay, so that's it. This is the City Analyst very basic tutorial. Of course, this is very important, is that we should adequate to your building or to your urban area. So the constructions, the solutions, the systems should be related with your area. So all that database should be updated with your information in your technology and solutions. And then there's some tricks that are related with the simulation. So don't work in clouds folders. Try to work in very small folders paths. Okay, don't use too long folders. There's some tips, I believe, that help to work with this software. So sometimes it returns some bugs when you run the script, so try to see what is the error here, and they have a very good and helpful GitHub platform, that is this one. Okay, so GitHub, if you Google it, you will find it, but it's here. Okay, the City Energy Analyst, where you can post your questions and they will answer briefly. So thank you very much, and see you next time.